All right, geometry, a little more practice with some proofs. Proving lines are parallel, or using these parallel concepts to prove some other things. So since we proved all theorems in section 3.2, we can use those those parallel line postulates / theorems as reasons in our future proofs, and we can also use their converses. All right, that we just added. So just to review, we've got the corresponding angles. I'm going to just do a real shorthand because we don't have a ton of space. So we have our corresponding angles, theorem. Sorry, that course I get this mixed up. That's the postulate. That's the one we just kind of assume to be true based on, just looking at it. So that's our postulate. The rest are our theorems. We have our alternate interior angles theorem, and the converse. We've got our alternate exterior angles theorem in the converse, and then we've got our consecutive interior or same side interior. So consecutive interior angles theorem, and that's the one about being adding up to be 180. So yeah, and then this little bit, how do we know when to use the converse or not? So if we're trying to prove that two angles are congruent, we'll use so we're not going to use the converse. We're just going to use the straight ahead theorem. The theorems state, assuming parallel, then we know these angles are congruent. So we'll not use it. If we're trying to prove that two lines are parallel, then we will use the converses. All right, the converses are saying, well, if these angles are congruent or supplementary or whatever, then we know the lines are parallel. So in this case, we're ultimately going to get to where we're proving that they're parallel. We're going to end up using a converse in this justification. So proof time. Remember, we've kind of had some set up. When we're going to do a proof, we're going to set up. We like to use, there's multiple types of proof, but this is a type we really like to focus on in this class. And this is kind of this T-chart, the statements and the justifications, the statements and the reasons. So we set up our statements, and then we have our reasons that we can make these statements. Ultimately, we can kind of assess what's going on here. This is how these proof problems will set up. They say, given that AB bisects CAD, so AB, this ray here, bisects CAD. And so we know that we might already be thinking angles 1 and 3 are congruent to each other. So we'll deal with that in a second, but that's one thing that we're told. And angle 1 and angle 2 are congruent. They want us to prove that AD is parallel to BC. So AD, this segment here is parallel to that segment, is what they want us to show. All right, so that's, you might be thinking about visualizing what we're going to do with, but we always start with the same thing. We always have to start with what we call the given. So in our proof, this part seems kind of redundant, but I want you to do it. Rewrite the given information. So AB, ray AB bisects angle CAD. So that is given, as well as angle 1 is congruent to angle 2. So those are kind of both given. You could write given twice if you want. But that's kind of our first step to this. All right, so then now we actually get to doing some work, right? That's just going to be always where we end up. And then where we want to end up is we want to, at the end, be proving this. We want this to be our last statement, that AD is parallel to BC. The first step I would take here, and there's a couple different things we could maybe do, but this bisector, we know that this angle, if AB is bisecting this, we know that this angle is congruent to that angle. So I'm going to write that down. I'm going to say angle 1, I know, is congruent to angle 3, but we need to justify that. We need to give our reasons, and that is our definition of an angle bisector. Definition of angle bisector. And like I said, I'm going to give you, I'm going to set up a Google Doc of these. We're going to kind of accumulate some of these things, but this is one type of thing we use is definitions, because we know what that means. We can set that up. All right, so that's our first thing. We know angle 1 is angle 1 and 3 are congruent. And we've actually already written, and I probably should have drawn this right at the beginning, angle 1 and 2 are congruent. It's good to mark up your picture as you go. So angle 1 and 2 are congruent. So now I can kind of see that angle 1, and you can see it a little bit here in proof as well, angle 3 and angle 2 are congruent. So if they're both congruent to 1, we can write that out. So angle, first, I know now that angle 2 is congruent to angle 3 as well. I've got it marked here. And this is kind of a new one. I'm going to throw this one at you, and you'll be using this some. This is from the transitive property of congruence. It's kind of like substitution. Transitive property of congruence. The transitive property of congruence says something like this. If A is congruent to B and B is congruent to C, that means A must also be congruent to C. If another way of saying that is A is the same as B, B is the same as C, A must be the same as C. We have a lot of transitive properties. You have transitive property of equality, transitive property of congruence, then there are other ones, transitive properties that exist. So it's just kind of going from A to B to C, and then comparing it, going straight leap from A to C. And really, what we're kind of doing is it's a lot like substitution. If 1 is congruent to 3, I can or if like 1 is congruent to 2, I can replace this 1 with the 2, so we have that. And then at this point, we can make our final step. Right, angle 2 and 3. Do we see that those would be alternate interior angles to these? What we want to show are parallel lines, and we know they're congruent. So that's going to be that converse we mentioned getting to. We know that segment AD, I'm just going to write exactly what I want to write here, is parallel to BC. And that's because these two angles are congruent. That is the alternate, the converse of the alternate interior angles theorem. So the converse of that, because those alternate interior angles are congruent, we know these lines are parallel. We've justified our work. We've proven that. All right, one more proof for us down here. In this case, we're given that the lines are parallel, and we're trying to prove that some lines are congruent. So I know line L is parallel to M. I'm going to go ahead and draw this on the picture. L is parallel to M. And then we know that line M, I'm going to draw a couple lines here, and we can do a couple arrows to show, these two are parallel. And there's actually another way there's this other concept of if this is parallel to that, then this is parallel to that. We're going to leave that out right now because we can do this without that. So I'm going to set up we call it 2-column proof, right? We got our statements and our reasons. And we're going to start with our given. So our given is that lines L is parallel to M, and line M is parallel to N. All right, so those are our 2 bits of information that are given. All right, so ultimately we want to prove that 4 is congruent to 10. I want to get from here to there. And we're just going to kind of walk our way across. First, I know this line is parallel to this line, and there are multiple different ways this could be done. But I'll show you one of them. So I kind of want to step my way across to and get to this. So if I can show that 4 is congruent to, say, 8, and then I can say, well, but then with these 2 lines being parallel, 8 is congruent to 10, and then I can do that transitive property thing again. So you could do it with the 8. We can also do this with you can do this with a few different things, but we can do it with the 6 as well. I could say 4 is congruent to 6 with alternate interior, and then those 2 are corresponding. So 6 and 8 are actually the easiest 2 to do this with. Yeah, there are other ways with more steps you could do it, and figuring these out. So, but we'll move on this way. First thing I'm going to use this 8 as my little kind of a bridge to get from 4 to 10. So 4 is congruent to 8. I'm going to say angle 4 is congruent to angle 8. And that is the corresponding angles postulate. So corresponding, I'm going to abbreviate that, angles postulate. All right, so the corresponding angles postulate tells me that that those 2 angles are going to be congruent. So then I can say 8 is congruent to 10. So angle 8 is congruent to angle 10. And that's and then I'm using the lines M and N's, the fact that they're parallel, and that's the alternate interior angles postulate. Alternate interior angles, not postulate, theorem. Not that that's a big deal. I probably won't like take off points if you mix up postulates and theorems. But theorems are things that we prove. Postulates are things we just kind of take for truth. And then finally, we can actually make this connection. Angle 4 is congruent to angle 10. If angle 4 is congruent to 8, and 8 is congruent to 10, then 4 is congruent to 10, and that is that same transitive property of congruence. So transitive property of congruence. And so that is a way we could wrap up that proof.